Okay. Today we're going to continue our foray into the Java collections framework and talk a little bit more about lists and then sets. So we touched on sets yesterday, but there's more to talk about. And just as a review, this is a considerable subset of the collections framework. These are the ones that I mostly use. I can't think of a time when I have used something that's not on this screen, but they do exist and are sometimes the ideal data structure to use for a particular task. The principle is to match the tool to the task. And as we saw yesterday, which version of the list that you choose can have a significant impact on your runtime. So that's why you need to be mindful of what the needs are in a particular program, and then would match that to the appropriate data structure. So again, as you saw, if you're going to be putting things, if you're going to require duplicates on a list, duplicates on a collection, then you need to have a list, because the choice is basically lists or sets, and if you need duplicates, then it must be a list. And the question is only what kind of list. So if you're going to be removing things from the front or the middle a lot, or even inserting things, or then a linked list is going to be a better deal for you than an array list. If you're not going to be doing that, then an array list is perfectly reasonable. Okay, so let's just delve in a little bit more, and this is typical of the constructors of all the concrete data structures that Java has. I'm just kind of illustrating it for array lists, but this actually applies to all the concrete ones. Okay, the first thing, again, I want to reinforce the idea, though, that if we're going to be using a list, then to define the variable as a list rather than the specific type, because that gives you the maximum flexibility in your class. So it may be, for example, that you start off thinking that an array list is going to be ideal, and then through testing, you realize that a linked list would be better. So if you have defined your variable in your object as a list, then you don't have to modify that at all. You can simply instantiate the linked list instead of array list, and just pass that in. So you don't need to edit that. If you define it as the concrete type, however, then you're stuck with that, unless you edit that. And the thing about editing is that once you have a class which works perfectly, there's only one way to go, and that's down. So editing a class is not a good idea. That's also why it's a better idea to use a debugger to step through your code to see how the variables are changing, than using a print statement. Because with a print statement, that will tell you when you're testing it whether things are going right or not. But typically when you start running in production mode, as it were, then all of that stuff is just a bunch of noise, and you want to take that out. If you just kind of put naked print line statements in, then once you move to production mode, you have to go in and edit your code wherever you put those print statements and then run in production mode. But here's the problem. You've taken a class, you've tested it and confirmed that it's working properly, and then you edit it. And once you edit it, there's no guarantee that it's going to still be working properly. Even if you think all I've done is just comment out some print lines, there's no guarantee that you haven't accidentally done something else. Working with the debugger, there, though, doesn't do that. Working with the debugger doesn't alter your code. So if stepping through with the debugger works and everything is fine, then you just run it in non-debug mode and you don't have to edit your code. So that gives you more reliability in terms of whether the class was working. Okay, so I got off on a tangent here. Okay, so what we've been using this constructor mostly, and this is the one that I mostly use. However, there, under the hood, with an array list, there's a given size that it starts with. So I can say, if I do it this way, I say, all right, I want to instantiate the array list, but I want to initialize the array underneath the hood to a size 5. Usually you want to give a bigger number if you're doing this. So if you remember, what the array list under the hood does what you had done in that one assignment, where if you had to expand your array, you had to create a new one that was a bigger size and then copy all the old stuff. Obviously, that's going to be a fairly expensive, compared to the other operations, a bit more expensive. Not application killing or anything. But if I know that I'm going to start off with at least 1,000 items, then I might as well initialize the array list with 1,000, and that way at least those first 1,000 won't have to have that additional expansion. Now the other thing, and this is very convenient, especially when you have situations where I want to convert one type of collection to another. Well, in particular, if I pass any collection whatsoever, in this case, let's say other list, but this could be any collection whatsoever, I can pass it into the constructor, and what that will do is it will take all the items in this collection and put them into this one here. This pattern is especially useful when you're doing setters and getters for, say, if you have an instance variable that's an array, that's a list, then what you want to do is, say, on the getter, you want to return a copy. Now, if you remember, arrays have a clone method that you should be using, and you must be using. Every time you have a setter or a getter with an array, it has a clone. Now, collections also have a clone method, but it's not as nice as the array one. So this pattern is really a better one for a setter or a getter with a collection. In other words, you return a new one with a copy of all the other stuff. We'll see, if we don't see an example of this quarter, we're definitely going to see an example of it next quarter. Promise. Okay, now adding to a list. Lists are different than sets in this regard. Well, of course, we've seen adding an item, which adds it to the end of a list. That's how it does it. However, the add method is overloaded in lists in that we can add to a particular index. So if I say add index and then the item, then it inserts the index it inserts the item at the index of the first argument and then shifts everybody to the right. So this is a fairly expensive operation if you have a large list. And then if you try to put something into an index that's less than the size of the list, then actually this should be strict. It should be strictly less than the size of the list. Remember, because the indices go 0 through the size -1. Again, the off by 1 business carries over to lists. So the first one's 0, second one, etc. We talked about auto boxing. So I cannot, that is, if I want to have a list, say with an int, a primitive that is not permitted. Only object, or wrappers. If I want to have a list with an int or double, I have to do it this way. So I declare it as a double. If I want this, I need to say something like list integer. In other words, always use the object wrapper when we're defining one of these collections. And then when Java first came out with this, it was kind of a pain because we had to always do this. See, because it would only accept an object wrapper, we had to explicitly wrap it. And then people bitched and moaned and said, oh, all that typing, it hurts our delicate fingers. And so Java came out with auto boxing, which means that, and it is kind of a nice thing, but again, it's like, I don't know, sometimes programmers are kind of real wimps. Don't mean to be too judgmental, but it's like, oh, all that typing, I don't want to type, so it's, so what auto boxing does, and just as a general thing, anytime I have an object wrapper context and I put a primitive in, then under the hood, Java will say, okay, I see what you mean to do here. I'll wrap it up and do that for you. So Java wraps this for you. It also unwraps it. So when I take it out, I can assign something in a container to a primitive if I want. So that's auto box. We've talked about auto boxing. Hopefully that's clear. Okay, so removing from the list, and this is also for now. This can be a little tricky. We can remove an item, meaning if I have a reference to that item, I can remove that item. So like if it's a string and I have a string that's the same string, I can say remove that string from the list. Or if I say I want to remove the item at this index, that can be done. So again, I'll get an exception if the index is not viable, meaning that index has to be between 0 and the size of the container -1. And if I have a list of integers and I say remove an int there, then it's ambiguous. Do I mean the index or do I mean the item? So in that case, if you're doing that, the safest thing is to explicitly wrap it. In other words, if I want to remove, instead of say removing 3 from one of this, and again, auto boxing will let me do that, but it's ambiguous if it's a list. Instead, I should, if I mean to remove the item at 3, then to make it absolutely clear that that's what I mean, then I want to wrap it like this. And there's no ambiguity here, because it'll say you're trying to remove an integer object, and then it's absolutely clear you want to remove the integer 3 from that container and not the item at index 3.
Is the new part of it necessary for the wrapping of it?
Yes.
Wouldn't there already be an integer 3 that exists in there that's trying to remove it?
Yes, yeah, there will. However, because of something called hash codes that we're going to talk about a little bit in the context of sets, a new integer 3 versus another integer 3 that have been created, say by Java, are equal. Yeah, so in other words, if I say, even though this is, I mean, that's a very insightful observation, because this is pointing to a different object than the one that would be in the container. So you say, how can I get those? Well, every object has something called a hash code that we're going to talk about in just a second. And so what it does is it uses that hash code to identify equality. Between that and also, there's also the equals method that we've already sort of talked about. So in other words, Java recognizes all integer objects with the same value as being equivalent. Is that, yeah. But you're absolutely right. I mean, and that is something to be concerned about, because when we're dealing with other objects where we want to make sure we're actually removing the right one, and that's going to come up with playing card in just a bit, when we try to put playing cards into one of these things. And I say I want to remove the ace of spades, then I need to make sure that every playing card object that's ace of spades is actually considered to be equal. And actually the way playing card is right now, it doesn't quite do that. It almost does that, but it doesn't quite. But anyway, but hold on to that thought, because it's an important one. Okay, so iterating, just as we saw in arrays, we have the for each syntax, where we can say for each item in a list. That's, as with arrays, that's useful only when we're iterating over the entire list. If I want to iterate over maybe some of the list, then we actually, then this is sort of a weird pattern, but this, it turns out, is a nice way to do it. Each collection has an iterator. That iterator will step through the collection using the two methods, the has next and next. And we've already talked about that in the context of a scanner. Remember, a scanner has a has next and a next, which, in addition to a whole bunch of other things. But that's the iterator piece of the scanner. And each collection has an iterator that it returns that will step through according to the rules of that list, or that collection, whatever it is. So the pattern that you would use there is is in a for loop. And so what's the syntax of a for loop? Initialization, test, and then increment. And this is what's weird, the increment is empty. That's legal. But the increment is done by a call to next in the loop. Okay, so why do all this typing? Because it's a lot of typing. If I want to remove an item based upon a particular criterion, then this is the safest way to do that. And in some cases, this is the only way to do that. In other words, let's say I already have a list of strings, and I want to go through and I want to remove everyone that starts with the letter A, say. Okay, so the thing is, I don't know where they are. If I try to step through using the index on that, and I remove the item when I hit the index, that's going to mess up the loop. So instead, the iterator for these has a method called remove, and so and we'll maybe not today, but at some point we'll see an example of that and why that's important. This is something that this has only come up for me maybe once or twice in a long time, but there is something called a list iterator that can go forwards and backwards. So the iterator can just go forwards, but the list iterator can go forwards and backwards. It's actually been several years since I've used one of these, so that's something we can not necessarily do. No. Now, we can convert a list to an array as follows. So let's say I had a list of integers. I can easily convert that to an array of integer objects using this pattern. So, and it's kind of a little bit weird, but every collection has a toArray method, and it's overloaded. So if I just use the naked toArray with 0 arguments, it returns an array of objects, which can be kind of clunky to deal with. If I just have an array of objects, then but I want to use, in this case, things that are associated with integers, then that won't do it. So I know there are integers on this list. I want to turn it into an array. Well, the way they have it set up is you pass in just an instance of the array that you want to turn this into. And notice that I can pass in a 0-length array because it doesn't use this array. What it does is all it uses this array for is to figure out what type of thing you want to turn this into. However, if I want to create an array of primitives from this, then I can't do it directly. I have to do some work. So what I could do instead is I could say something like int, array. I have to initialize the array, and the way to initialize it is I could int, and then every collection has, a method called size. Now, arrays have length, strings have length, collections have size. So I have to initialize that and then loop over the thing. So I can't do it directly. I can't do it in one call, in one statement like here, but I need to, and I know that's some writing with a mouse is not my strong suit. Anyway, so if I want to convert a list of integers into an array of ints, I need to just write some code. There's no getting around that. Now, it turns out it's fairly convenient to convert an array to a list. So let's say if I have an array of strings, and I want to convert it into a list of strings, then there's a method called arrays.asList, and I pass in in this case, the list, or it could even be a collection. Or no, it has to be a list. I'm sorry. Yeah. Okay, so now, just as a little pop question, what type of thing is this as list thing? What is that? Is it an instance variable? Is it a class variable? Is it an instance method? Is it a class method? A class method. Why?
Because you're calling it as part of the arrays class?
Correct, yeah. Whenever you call a method using the name of a class, and you don't get a red squiggly, although I gave it a red. Assuming that this is legal, which it is, because I'm using the name of a class and not the name of a reference to an object, then the only thing it can be is a class method. Now, it turns out that for whatever reason, the list that they return is immutable, meaning you can't, even though normally in a list you can put things in and take them out, when you do it this way, you can't. You say, well, what if I want to? What if I have an array of stuff, and I want to make a list of things, but then I want to modify it in some way? Well, then we can use that overloaded constructor to create, say, a new array list or linked list, if that would be the choice, and passing in this case, it would be passing in this list that I got back from here. That's just how to do that. Okay, so that is more or less everything you need to know about lists, almost. Sets. Now, the thing about sets, as we saw yesterday, sets cannot contain duplicates. An add will only add the item if it's not already in the set, and there's no concept of an index. That's kind of a key here. The two main concrete sets are hash set and linked hash set. And the difference is that with a hash set, when I say arbitrary order, it puts things, it's a little under the hood. It uses this thing called a hash code that every object has. That's what ensures that actually the hash set does it in a very efficient manner, but that's also what keeps it from, in a hash set, that's what helps it tell one object from another. All right, now I don't want to do the sorted set just yet. Okay, so that's the hash. Oh, yeah.